And just like that, it's time for our last video of the year. This is covering the most important topics from first semester that we need to review for your final and just for going forward. So one of the first things we looked at was how to find midpoint and distance. So to find midpoint, it really is just finding the average of the x values and the average of the y values. So I add my two x's together, so -3 plus 7 over 2, and then 4 plus 10 over 2. So -3 plus 7 is 4, divided by 2 is 2. 4 plus 10 is 14, divided by 2 is 7. The other thing we did with midpoint was we did if we want to find what an endpoint is. And remember, I didn't write a problem for this, but that's where we would use our table and we would write E, M, E, and put in our endpoint, put in our midpoint, and we would do the little arrow thing. So just a recap of that. So let's say instead I wanted to find the distance between those 2 points. So if I want to find distance, distance is really just a fancy Pythagorean theorem. So to do that, we put it in the table, and we see how do you go from -3 to 7? We go up 10. How do you go from 4 to 10? We go up 6. And then we're going to use a squared plus b squared equals c squared, where these sides are my a and my b. And in this example, both of them are positive, but it actually doesn't matter whether they're positive or negative, because when I square it, I'm going to get a positive. So this would be 10 squared plus 6 squared equals c squared. So c is going to be the square root of 136, and I'm just going to leave it like that. But sometimes it might ask for a decimal. After we did our basic unit, we had everyone's favorite unit on logic, which we won't be putting on the final. Then we looked at parallel lines for 2 units. So what's important about parallel lines is remembering that we have vertical angles, which are congruent. And then we learned about alternate interior angles. Those are the ones that are kind of the inside of my Z. Okay, so in these, the picture on the left, angle 2 and 4, 5 and 7 are all congruent to each other. And then 1 and 3, 8 and 6 are all congruent to each other. And the red plus the blue equals 180. Okay, so the different colors are supplementary, the same colors are congruent. So in my first problem, these are in the same position, so they're called corresponding angles. So 11x minus 2 equals 75, so x equals 7. The next problem, we have the z going on, which means they're alternate interior angles. So they're equal, so 8x minus 4 equals 60, so x equals 8. See, parallel lines aren't that bad. Then we looked at things with angles in triangles and something called the exterior angle theorem. So we learned or reviewed that angles in a triangle add to 180, so 38 plus x plus 2 equals 180. So 2x plus 40 equals 180, which means that x equals 70. And I tried to find a good example for exterior angle theorem. This one isn't perfect, but exterior angle theorem, an exterior angle is when I take one side of the triangle and just shoot it straight out. Okay, this angle that's formed with the outside of the triangle is called exterior, and it is equal to the sum of the remote interior angles, aka the 2 interior angles it's not touching. So this would mean that 9y plus 11 equals 146, and then we can go from there. So 9y equals 135, so y equals 15, okay? And you know, someone out there right now is like, well, I could have found it, but I could have subtracted from 180 and then added everything and equaled 180. True. But if my exterior angle has, if everything involved has a variable, then it gets really annoying to try to do that method. But hypothetically, does it work? Yes, it's just not always the easiest. We also looked at isosceles and equilateral triangles. So in isosceles triangles, your two base angles are the same. To find the base angle, you put your pencil on the two sides that are congruent. So that goes there and there. So these two angles are congruent. So if the left one is 52, then the right one is 52. And now that I know that, I can add all my angles in the triangle, and they're going to equal 180. So 52 plus 52 plus 14x plus 6 equals 180. So 14x plus 104 plus 6 is 110 equals 180. So 14x equals 70. And x equals 5. 5? Yes. Okay. The next example, I have an equilateral triangle. In an equilateral triangle, all my angles are equal to 60 degrees. So I can find x. So 4x equals 60, which means that x equals 15. And so if this bottom angle is 60, it's supplementary with y. So 60 plus y equals 180, which means that y equals 120. I could have also used the exterior angle theorem from the other slide that we just looked at as well. After looking at things with those type of triangles, we looked at congruent triangles, and we had a few theorems that proved things were congruent. We had side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. Two things that didn't work were if I just don't have enough information, and then AAA and SSA. So these were not necessarily congruent. They could be congruent, but they're not necessarily congruent. And when we were marking triangles, remember that it was not about whether they looked congruent, it was about whether we could prove it. And so we had things like vertical angles are congruent. Whoops, vertical angles are congruent. Then we had figures where I had a shared side, and that was called our reflexive property. And we did all sorts of proofs and everything with it. I'm not going to ask you to do proofs on the final, but it's important to know my theorems here and be able to recognize them. So we still need just our general properties of what I can add and why to a diagram. We also talked about bisecting, cutting things in half and making them congruent, that sort of thing in this unit. After congruent triangles, well, we went into the centroid and median and all of those favorite things that you've forgotten about triangle centers. They aren't really going to be the center of your life. See what I did? Had to give you a last joke. Going forward, so we're going to skip to similar triangles, which are still a really important idea, since they're the entire foundation for trig that we looked at this semester. So similar triangles, we had less theorems. I had angle proves similarity, so two angles are congruent. And then I had side angle side and side side side. But when we use an S here, we're saying the sides are proportional, not congruent. Okay, so when I use S there, we're meaning proportional. Hopefully I spelled that right. Don't tell your English teacher. Okay, so for instance, when I want to solve something, first we need to find our corresponding sides. So for this one, I see 6 is between 2 and 3. and 4 is between 2 and 3. I'm looking at the angle marks. 8 is between angle marks 2 and 1, so y is between 2 and 1, and 7 is between 1 and 3, x is between 1 and 3. Okay, I just need to make sure all of these are lining up. So my pair where I have a number in both is 6 over 4. So 6 over 4, so I just made that left over right, and now I'm just going to choose one of the other ones to do. So I'm going to do green, so 8 over y. And then we did a lot of cross multiplying this unit. So 6y equals 32, and we're going to OMG get a decimal, but that's okay. So y equals 32 over 6. And I don't have a calculator, so we're going to leave this as 16 over 3. Then I go back to my yellow again because that's the one where I have my original pair that match up, corresponding parts. And then we're going to do 7 over x. So I get 6x equals 28. So x is 28 over 6. Once again, I don't have a calculator, so we'll just reduce this to 14 over 3. So that's an example when we had separate triangles. We also had these ones that were kind of nested triangles, and it's an application of similar triangles. And here was where we had a lot of possible ways I could set stuff up. The important thing is that I'm using corresponding pieces. So here I could do x over 1 equals 6 over 2. Well, x over 1 is just x, and 6 over 2 is 3. So that's a way I could do it. I could have, I'm going to do this in a different color, done x over 6 equals 1 over 2. Once again, when I solve that, I'm going to get 3. What you don't want to do is I call it crisscross applesauce. Bum, bum. Don't do that. Wrong. Okay? Because then you aren't matching up corresponding pieces. Okay? So the only thing we don't want to do is kind of mash stuff up. But pretty much any other pattern works. Bottom over top, top over bottom, right over left, etc., etc. And that is our entire review of first semester. Wow, those were our key points.